In this video, I'm going to show some examples of word problems with multiplying and dividing fractions. Question 1 says a furniture maker builds chairs, tables, and cabinets. She has a supply of wood that is 7/12 pine. She will use 1/3 of the pine to build chairs. What fraction of her wood supply will be made into pine chairs? To help make sense of this problem, I'm going to draw a quick little bar model here. And I'm going to make this rectangle represent one whole. And I'm now going to divide this whole into 12 parts. So there's 4, and then each one of these I need to split into thirds. So there's my 12 equal parts. I know that 7/12 of these parts are pine, so I'm going to go ahead and shade in 7/12. This will be the part that represents the amount of wood that is pine. Now the question says that she's using 1/3 of the pine to build chairs. So I'm going to take my whole here, my fraction parts here, and I'm going to split them into thirds. So I'm splitting the entire thing into thirds. She's only using 1/3 of the pine. So the part that this person is using to build the chairs is only 1/3 of the blue shaded part. And I'm just going to shade over those thirds. So it would be this part, this, this, and this. Just those parts. That's the pine that she's using to build chairs. So we can see that our whole is now split into 36 parts. And the part that we're using for the pine is this 1, 2, 3, 4, 5, 6, 7 parts right there. So our answer is 7/36 of the whole. Now what we really did in this diagram is I found 1/3 of the 7/12, and that gave us 7/36. If you look for a pattern here, what we really just did is we multiplied 1 times 7 and got 7, and 3 times 12 and got 36. So what we really just did here is multiplied the fractions. Question 2 says a student is making scrapbooks for friends. Each scrapbook is decorated with 1/8 yard of ribbon. There is 5/8 yard of ribbon on a spool. If the student uses all the ribbon on the spool, how many scrapbooks can he decorate? I'm again going to draw a quick little model here, even though this is probably a problem you can do in your head. I'm going to go ahead and divide this big rectangle, which will represent my whole. I'm going to divide it into eighths. So there's fourths, and then half of fourths are eighths. Then I'm going to shade in the part of the spool of ribbon that we have, which is 5/8. 1, 2, 3, 4, 5. The rest of the spool is empty. And it says each scrapbook takes 1/8 yard of ribbon to decorate. So this is 5/8. It takes 1/8 for each scrapbook. So here's one scrapbook. Here's 2 scrapbooks, 3, 4, and 5 scrapbooks. So our answer is C. If we look at what we just did here, we started out with 5/8 of a spool of ribbon. Then we divided that 5/8 into groups of 1/8. Even though I wrote 1, 2, 3, 4, 5 on the bar model here, what each of these sections really represented was 1/8 of the whole. So the fraction that they represented was 1/8. Now all we cared about were how many sections of 1/8 could we make, because each section of 1/8 was used to decorate one scrapbook. But we were trying to take our 5/8 of a spool and divide it into sections of 1/8. When we divide fractions, we multiply by the reciprocal. So we have 5/8 times 8/1, which is 40/8, which gives us 5 scrapbooks that we can decorate. Question 3 says a student is setting up a relay race around the perimeter of a park. The perimeter of the park is 1/2 mile. He wants to place a marker every 1/10 of a mile along the race course. How many markers will he place along the race course? Here's my bar model for this problem. I'm going to draw this fairly large. And this represents 1 whole mile, but the perimeter of the racetrack was only 1/2 mile. So this is the only part that we care about, this part right here that I'm going to shade in blue. This represents the distance all the way around the track. And we want to put a little marker every 1/10 of a mile. Now right now our hole is not divided into tenths of a mile. So what I'm going to do next is, instead of dividing this into halves like it is right now, because right now we have 1/2 right here and 1/2 right here, right? What I'm going to do next is I'm going to divide the whole into 1/10. So each one of these halves I'm going to split into 5 parts so that we have 10 total parts. So now each one of these little sections right here represents 1/10 of a mile. So we just want to know how many markers will he need to place along the course. And this is where this question gets a little bit ambiguous, but for the purposes of this, I'm going to assume that they're not placing a marker at the start of the race, because I'm going to assume that the start of the race is clearly defined by some sort of like beginning line. So what I'm going to do is I'm going to place a marker right there at the 1/10 mark, then at the 2/10 mark, the 3/10 mark, the 4/10 mark, and then at the finish line right there, the 5/10 mark. So we have now 5 different markers. And the problem that we just did is we took 1/2, we divided into groups of 1/10, and we got 5 holes. We multiplied by the reciprocal of 1/10, which gave us 10/2, which again equals 5.